My name is Grant Ingersoll. I'm the CTO and co-founder of Lucidworks. I apologize in advance. My voice is pretty scratchy this morning. I picked up a cold on the way here, so do my best to power through. I'm going to be talking about how we've been integrating a number of machine learning capabilities into our platform that's built on top of Solr and Spark. I really wanted to call the talk this, but the title was already too long, so I'm just going to go with what I have. This isn't a product pitch, but as a company based here in San Francisco, we build a product called Lucidworks Fusion. It's made up of 3 parts. I kind of like to think about it as App Studio as a UI layer for building advanced search and discovery applications. Fusion Server is all the plumbing that goes into actually building a search and discovery application. Think of it as scaling and security and connectors and all that kind of stuff. Basically all the stuff that you as developers have to do but don't want to do. And then the AI stuff is, of course, marketing, buzzword compliant terminology that means machine learning, natural language processing, statistical analysis, experimentation, etc. In other words, all the stuff that most developers these days want to work on but don't have time to work on because they're working on the other stuff. That's the product pitch. Underneath it all, it's built on 2 key open source technologies, Solr and Spark. If you haven't heard of them, just go Google them. Very popular. We as a company power a whole bunch of sites you probably use every day. Places like Reddit, Home Depot, Lowe's, REI, and a whole bunch of banks and things like that in the enterprise. So, what's been our journey with machine learning? A few years back, we brought Spark into our platform. We said, hey, Spark has MLlib. Great. There's things like logistic regression and collaborative filtering, alternating least squares, all these fancy terms for machine learning. Started playing around with it, integrating it in, found we had to do a whole bunch of work to actually make it work in production. For instance, Spark kind of has this opinion that the only place you do machine learning is in Spark. Spark is great for building machine learning models, but then oftentimes real-time systems, you just need a model served up in production, and Spark actually doesn't do that very well. In addition to that, the world was starting to really change and really advance pretty rapidly with a whole bunch of deep learning projects and other approaches to machine learning. So we went on a little bit of a journey and said, let's go start looking at what's out there. Our customers build applications on top of our platform, so it was important that we were able to deliver them all the different types of ways they might want to build machine learning. And many of them were coming to us asking, hey, could we have PyTorch, could we have DL4J, so on, so forth. So we investigated, dug in, and then the reality is most people had just decided, let's go with Tensorflow. This isn't a talk about Tensorflow. This is a talk about how we approached integrating these things. It's actually still evolving as the world is changing all around us constantly. Some of our use cases, not necessarily your use cases, but I at least wanted to ground this talk in what we are trying to accomplish with machine learning. I generally, even though our platform could be used as a general purpose AI platform, we tend to focus very much on search and discovery related tasks. In other words, how do we give you better access to information? One of the easiest ones to think about that you can actually get a really nice improvement out using machine learning is the simple type ahead box that we all know from search engines we use every day, Google, Amazon, so on, so forth. Basically a character-based predictor that says, this is what we think the user should be querying. The interesting thing here, of course, though, is you want to intersect the type ahead with things you actually have in your search index, right? So it's not enough to just be like what on your iPhone where it predicts words that can be completed by this. You want to predict words that will actually lead to good results for your users, right? Next up, we often get customers, as we do a lot of work in retail, a lot of our customers want to do sentiment analysis, things like that on reviews. It's another use case. Things like recommendations. I kind of think of search and discovery, search and recommendations as two sides of the same coin. Search is great for when you know what you're looking for. Recommendations are great for when you kind of know what you're looking for or you don't really know what you're looking for. Last but not least, ultimately, I think the whole search and discovery world is really moving towards this model where you're going to kind of think about how you scale your answers, the way you answer users' requests across a number of different things. Question answering being one of them for when you want these conversational or very short transactional things. Search when you need to give people a bigger view of the world. And then even beyond that, actually kicking off full workflows for when you already know what a user wants to do. I kind of liken it to a good concierge at a hotel. That's probably because I travel too much. But the concierge, a good concierge, if you go to them and say, hey, when does the shuttle leave for the airport? 5 p.m. Question answering. If you say, what are some good restaurants near the hotel? That's 10 blue links. That's search, right? If you say, hey, how do I open up a new loyalty account with the hotel? That's workflow. And in fact, a good concierge would say, well, hey, here's the form. Let me help you fill it out, and I'll send it in for you. Right? That's the future of where all this stuff is going, right? Because we as users don't want to have to waste time when we don't need to, right? So that's all well and good. Those are some of our use cases. Why did we care about adding deep learning in TensorFlow? Like I said earlier, the world's changing very rapidly. If you actually go to any academic conferences or a large majority of industry conferences these days, pretty much everybody, all they do is talk about deep learning. We wanted to be able to leverage all of that work. There's a lot of really good work out there, especially on the second bullet item. We wanted to make sure our platform was able to give people richer and deeper access to what I call dense data, image, and audio files, right? Search engines like Elasticsearch, Solr, et cetera, traditionally have worked off of sparse text-based data, metadata. They're really, really good at that. But they're actually not that good at dense data like images and audio. You have to do a lot of tricks to get the engines to do it. It is possible, but not easy. And then the third one I kind of hinted at already. We want to just make sure in our platform that people are able to do the types of models they want to do. And I think even more importantly, this fourth one, that what you're starting to see really evolve out of tools like TensorFlow, et cetera, is you really have this universal machine learning workflow that you can go with. And then, of course, last but not least, I'm the CTO. I travel around and talk to a lot of customers, and I'm just tired of answering the question of what we're doing with deep learning. So why not? There's actually some pretty good valid reasons. You don't work at one of the big guys, right? The Apples, the Googles, et cetera. You may not have enough data for this or the right use cases. I've seen a number of times good in paper is not always good in practice. People publish these research papers, and they're very small incremental gains over state of the art, and they do a lot of work to get to those, right? I'm a big fan of trying to make things as simple as possible. If I can get a 90% solution using simpler approaches in 10% of the time, which is often the case with some of these simpler models or even hand-tuned systems, those can then buy me time that allow me then to bring in a richer, more robust system like deep learning, right? Logistic regression is still a really damn good approach to a lot of problems, right? And then last but not least, if you don't have expertise in this area, right, like if you can't do the simple things, what makes you think you're going to do the way harder things, right? So be realistic about that. All that kind of came to a head for me as I was trying to make this decision on some of our directions about how we should do this when one of the team members on our team came back to me and sent me this email. Or I think it was a Slack message that was basically like, on the side, he does all these competitions. It's great practice for him. And he said, hey, I came in 12th place out of like 4,500 people using this ensemble deep learning approach. And this was like the third or fourth contest that he did. And part of me was like, I just need to keep this guy happy. And he's clearly doing some really interesting work. And it fits with where we're going. So let's bring it on. So what are some of our technical needs? Because we already had a lot of things in place, I didn't want to have customers have to go do some, unnatural act in order to work with deep learning in our system, right? So I kind of wanted to avoid this one-off implementation, if you will. I'm not quite sure we're there yet, but I think we're getting close. Wanted to make sure we could help our customers get to production faster, and most importantly, because we're powering lots of really large sites with very high transaction volumes, we need to make sure this stuff is fast when serving, and we need to make sure the quality, that the customer is able to determine the quality of the system when they build it. And then last but not least, because a lot of these models allow you to kind of take and learn from parts of the model, we wanted to be able to say to our customers, hey, you can start with some of the existing models out there and then train in your environment. So where did we end up? And this is still open for debate. I'll talk in the next slide about some of the pros and cons. But we ended up choosing a project called MLeap, which is basically a lightweight abstraction layer over a bunch of machine learning projects. You can go and look up the GitHub on that. The cool thing is it supports Spark. It supports actually scikit-learn, which is a pretty popular Python library. It supports TensorFlow, and actually they've now support XGBoost as well. And kind of these days, more or less state-of-the-art XGBoost and TensorFlow. XGBoost for kind of your structured machine learning challenges, and your TensorFlow for things like images and all of that kind of stuff. More importantly, it gave us a platform whereby we could bring in other models without having to re-architect everything else in our system, and it already kind of fit with what we were doing. Some of the pros and cons, like I said, it supports many of the top ML libraries. It's portable. We had actually, remember I said earlier that Spark doesn't really do serving outside of Spark. We had built a little shim layer that allowed us to serve Spark models in our pipelines. Turns out MLeap was way faster than what we built. Kind of shows the power of open source here. That's kind of what you see highlighted on the right is the mean times between the two. Some of the cons, if you go look at GitHub, I'm a big believer that when you evaluate an open source project, you really need to look at kind of history of commits and contributions to see how active a project is. You don't want a project that's too early, but you also don't want a project that's already stagnated. I'm still not entirely sold on this one. Some of the new architecture stuff we're doing, I think we'll just get rid of this need as we do more and more microservices approaches. It only supports Java and Scala right now, which was fine for us. Our back-end system is all Java and Scala, so that was fine. And it doesn't necessarily support all the latest and greatest libraries out there. And in fact, that's part of the challenge in adopting any machine learning library these days is much like the JavaScript world, it seems like there's a new framework every week, right? And in fact, there's others coming out there, things like MLflow, Kubeflow, and various other systems are all, kind of encroaching in on this space as people recognize that, yes, there is this need to be able to go across a lot of different models. What does all of this look like? This is kind of a rough architecture, but you kind of think about in the middle there. I think I actually have maybe a laser pointer. I don't know. In the middle there, we basically keep everything we do in Solr. Solr is our database, effectively. Many of you in the room are probably like, wait, a search engine as a database? Yeah, it's actually a really damn good database, in fact. We have in there what we call a blob store. We store like 10, 20 gigabyte files, kind of like an S3 if you want. More importantly, though, we keep all of your content, and we keep all of our user behavior content in the search engine as well. Right? So all your clicks, your add to carts, your conversions, all of that stuff goes right into the search engine. And if you think about it, that data is what almost always powers your machine learning algorithms, right? So now we have co-located our core content with all of our user behavior, and effectively then your search engine becomes data as a service. right? In fact, we have some car companies that take and put all of their autonomous vehicle tracking information into the search engine, and then their machine learning and data scientists come in and say, I need a data set of 1 million rows that has these 15 features. Search engines are really good at doing that kind of thing. Especially Solr, which has a really cool capability called streaming expressions, which can basically do large-scale data warehouse operations and do math and do a whole bunch of other things right in the engine as it's coming out, scoring and ranking that data such that you can then feed it in to your downstream systems. So that middle layer then often feeds in via Spark to some offline training, either Spark ML, Tensorflow. You want to use Keras, you want to use all your existing tools. Those all work with us. And then in our product, then we also do all the heavy lifting to store that those machine learning models after we've done validation, crossfit, all that kind of stuff, into what we call our blob store. And then that goes and serves out to our request processing layer, either at index time or query time. The nice thing here, like I said, is no matter what the model type is, when it comes to those serving layers, we just go say, hey, give me the model that the user said they wanted to work with, and we put it into our pipelines, and away we go, right? So we use this for many of the things I talked about in the use cases. We also do things like learning to rank off of that, where we automatically learn relevance functions, so on and so forth. Now, usually I give this a demo. Today I'm just going to do some screen captures in the interest of time. So a couple of demos we've got in place. Happy to talk offline if we need to, or if you want to see any of these. The first one is a sentiment analysis one where we trained off of a bunch of Amazon review data as well as a few others. Kind of shows the power of the approach here. We use things like fast text and TensorFlow and a bunch of other things to actually build out in our own internal tests a really high quality sentiment analysis model that we will actually be shipping very soon. The second one here is another interesting one. When we first started that QA project that I talked about, we basically said, well, let's go see if we can reproduce an existing QA data set. So there's actually some really nice QA pair data sets out there for building question answering systems. One in particular that gets a lot of interest in the research community is called the Insurance Q&A data set. You can go look it up there. 27,000 pairs of things like, can my wife drive on my insurance? And the key idea that we're trying to build first here was instead of thinking about question answering as just kind of bootstrapping off of whatever raw data you have, many companies already have lots and lots of FAQs. And so one of the first easy wins you can get by adding in and taking on something like question answering is saying, how can we just start mapping users into the existing knowledge we have, especially FAQs, right? You think you've been in business all these years, you've done all this work to build these FAQs, and then let's make sure we still leverage that to then go bootstrap out into a much deeper and richer QA system. Because one of our goals is to build a QA system for enterprises and for internal things, not just consumer-based QA systems like Alexa or Siri or any of those kinds of things. A couple of screenshots from that, which are probably eye charts on this size screen, and I can't scroll in, but one of the things that you really try to do here is make sure the big contribution that deep learning brings here is that NLP layer that can take and process the user's question and then effectively do a similarity match to other existing questions. Because again, users are notoriously bad at asking questions the way we as developers want them to ask questions. So the NLP here and these deep learning systems can be really quite good at bringing them in. So here I asked, can my spouse be on my insurance? Along the side here, you see here are all the other similar questions out of those 27K data set that actually are very similar. Things like, is my spouse covered on my auto insurance? Does my spouse have to be on my auto insurance? Does my spouse have my auto insurance, right? And in fact, if you ask other variants like, can my boyfriend or girlfriend or significant other be on my auto insurance and vice versa, you can kind of sit there and play around with it. It's pretty neat because traditional approaches like in search where we would do string matching things like edit distance and various other kind of heuristics and rules would take a long time and are very flaky when it comes to real world systems. I've been building NLP systems for a long, long time. And while I can tune them really nicely to a very small subdomain, the deep learning-based approaches just kind of blow all of that stuff out of the door. So I'm able to leverage that existing knowledge I have and get way richer gains from it all. The last demo that we're working on really, I think, is where we're in the long term trying to go. This is a work in progress. And there is a lot of work to be done here. I think in order for us as a platform to be able to deliver out a QA system that folks like you can then go build on top of, we really need to be able to offer an ensemble type approach that takes and gives you access to what are called symbolic, i.e. the old way of doing things. The FAQ stuff I just talked about that allows you to leverage existing pieces, deep learning stuff that actually gets in and tries to find exact answers, and then also still the tried and true template and regex-based ones, right? Such that you can then build out this kind of ensemble and think about having it, do a shotgun across a bunch of different approaches and then come back and join and learn from which results are best. So in this demo, we take and we have this little open source project that we basically index things like Stack Overflow and Apache's mailing lists and stuff like that. We provide search over at UI and some analytics and basically analysis of communities. I said to my team, hey, it's great to go reproduce academic research, but I want you to see what kind of progress we can make doing this on a data set that you haven't seen before. A data set that's noisy, a data set that is really complicated, right? Lots of different data sources competing, so on and so forth. So in this demo, we've been working on bringing in a number of different approaches. This slide's slightly out of date. I do believe we have some TensorFlow models for this data now as well. And actually bringing in the symbolic and all of that approaches. Again, a little bit of an eye chart, but here's kind of the high level of what it looks like. User request comes in. We shotgun it across 3 or 4 different pipelines, some trying to match FAQs, some trying to match using symbolic approaches, so on and so forth. Underneath the hood of all of this stuff, you can kind of generalize a lot of what's going on in question answering to things like the very first thing you always want to do in these systems is try to predict what the user actually cares about. That's the answer type classification. That prediction then gives you both a strategy and the tactics around how to then proceed, right? So if somebody asks, hey, what time does the shuttle leave? The classifier would say, oh, this person's looking for a time. And then you might just say, oh, I have an inferencing engine or I have an ensemble approach that actually specializes in that, and I'll short circuit right to it. Or perhaps it'll say, give you enough information, you hit a cache, and then you'll just return back the answer because you already know it, or it'll hit rules, etc., right? And then you go on down the chain. You can do things like NLP annotation, markup parts of speech, etc., if you want to. And then we basically build out a query to Solr. Solr gives us our candidates that we then want to score. Believe it or not, most of these QA systems have a search engine underneath the hood that they then get candidates back from and then do a deeper set of work on a smaller number of documents, right? And then so on and so forth down the chain, get the answers back out, perhaps use machine learning to re-rank your results based off of your user feedback loops on what people actually click on or look at, so on and so forth. It's kind of interesting once you start playing around with this, because as I start to work with it, depending on the question, some approaches work better than others. So in this one, I say, is Scala strongly typed? And in the very first one here, we're doing this deep learning-based approach, trying to find, essentially answer passages just based off of pure deep learning approaches. And you can kind of see in the, you can kind of see, we get in the realm here of a passage that has the right things and the model basically is able to spit out. But you can also see, like in the second and third one, we return the top 3 from the system, that they're not necessarily that good of answers yet, right? If we then look at just doing an FAQ-based approach for this particular question, it actually pretty obviously bombs. There's some mention of things like typing in there and all of that. And obviously our formatting is not all that great, but it's not that good of an answer. And interestingly enough, the symbolic approach actually does quite well here, because the user's verbiage is pretty much word for word in the question, or in the answer. So there's some resources for you. Thank you very much for joining me today.
I didn't know I was broken until I found my missing piece.